What's good, Year 11 Journal Math goers? Mr. Herman here, and this video is going to be looking at Lesson 4, Exercise 6D, finding the equation of a straight line graph from its intercept and slope. So two things, intercept and slope. Two things will be provided to us via a graph, and then from this graph, the intercept and the slope, we are going to write an equation, y equals something. You got to know that the format is y is equal to a plus bx, and if you remember or recall from the previous videos, a is where the line hits the y-axis or the vertical axis, and b is the slope. How much is this graph going up or down by? It feels like I'm doing this fancy move. And then when you get these two forms of information, you can put it into the graph of y equals something. So here's the step-by-step guide. Number one, we're going to write the general equation of a line in intercept slope form, y equals a plus bx. We always write this so we know what we're looking for, namely a and b. Number two is we're going to read the y-intercept from the graph. Where does the graph cut the vertical axis? Number three, we're going to find the slope of the graph by using two well-defined points on the line. And well-defined, I'm going to underline because the well-defined just means another fancy way of saying whole numbers. Okay, we're looking for two coordinates, or 2 points that are on that line, and they have to be whole numbers. There's nothing stopping you from using maybe decimals or halves, like 3.5 or 9.25. It gets a little bit tricky though, so we want to make sure that these points are well defined. Your first point can be the y-intercept of the graph, so that's going to be in the format of when x is equal to 0, y is going to equal where that intercept happens. So we'll use this example of this format in the first example. The second point can be any other point that you choose on the line. It can be any point, it doesn't matter. Regardless of what 2 points are used, when you put it into the equation y2 minus y1 over x2 minus x1, you will always get the same answer. You might get a different altered answer that's off by a few decimals if you're going to be using not well-defined points. Okay, so all we got to know is choose one point, which is this one, choose another point which is on the line, substitute those points into this formula. That will give you the slope, or in other words, that will give you b, and then we just substitute a and b into our equation, and we have an equation from the line. So let's have a look. We're going to determine the equation of the straight line graph, or graphs to the right. There's two of them. Right? So the very first thing is we're going to write this in the format of y is equal to a plus bx. This is what we're looking for, namely a and b. The a is where the y-intercept happens. So y-int, call it y-int for short, is equal to the point at 0, because it's always x equals to 0, and clearly we can see that this intercept happens at 2, and y is equal to 2. And this implies that our a is equal to 2, or specifically positive 2, but we'll just keep it as 2. So we found our a, that's the easy part. And I purposely wrote this 0, 2, because this is going to help us with the next part. We're going to find another point on the line to find our b. So the best point that we can use, there are two. We can use this one here, which is 3.5 and 7, but to get this a bit more well defined, I'm actually going to use this point here. And this point right here is when x is equal to 5, which is down here on the x-axis, y is going to equal to 9. So 2 points. So 2 points, we're going to use 0, 2 and 5, 9. And now I'm going to label these x1, y1 and x2, y2. x2, whoops, there's a y2. And the equation that we're going to use, which is from up here, y2 minus y1 over x2 minus x1, we're just going to do a straightforward substitution. Our y2 has been defined as 9, and our y1 has been defined as 2. Or in other words, how much does this go up by in the vertical axis? This is going up by 7 units, or 9 minus 2 units. And then how much is this going across by? 5 as our x2 minus 0 as our x1. It's gone from 0 to 5, so we know it's gone 5 units. 9 minus 2, 7. 5 minus 0 is obviously 5. Now we don't leave it in this format, 7 over 5. We're going to wipe this as a decimal, and this is 1.4. So our slope is 1.4. In other words, every unit we're going to the right by 1, we're going up by 1.4. 1 unit to the right, up 1.4. Up by 1.4. Tongue twister. So we've got our A value, we've got our B value, and I should be specific here. I should say that B is equal to this, which is equal to 1.4. So our final format in this case is y is equal to 2, because that was where the intercept is, plus 1.4x. And there is our defined equation based on looking for A and B. We know that this has to be a plus 1.4 because from left to right it is going up, so this is where the plus comes into play. The second example, and the last example, again we're going to be writing the format of y equals a plus b, and it's just the same process. We're looking for a and we're looking for b, but this time we know, just looking at the graph, that this b value here, the number in front of x, has to be a negative. So this has to be a minus because from left to right it's going down. Okay, we know where our y-intercept is. The y-intercept is easy. Y-intercept happens when x is equal to 0, y is going to equal 35,000. 35,000. So that implies that our A is equal to 35,000. You can't find shortcuts. You shouldn't use 35k because k is traditionally used to indicate thousands. Don't do that because we're now dealing with formulas. Just leave it as the whole number. Okay. And try not to put commas in there as well, because we are dealing with coordinates that already use commas. Just leave it as this plain value, like so. Okay. Alright, so we're going to find now our B. And our B is equal to, remember this equation, the difference between the y's over the difference between the x's, which is a ratio. We have one defined point, which we're going to use as x1, y1 here. Let's look for another defined point. Let's go back to that graph and let's look for what we should use for our point here. Now, it's safe to assume that we can use that point because that's at the at another intersection, and it does look like it hits 9. But I'm not going to do that. I'm not going to use that point because you can see that there's a little gap. Little gap in between where the line hits an x-intercept and to 9. That's not a well-defined point. It's misleadingly looking like a well-defined point, but it's not. So we're going to go to a point where I know it's going to hit one of the intersections on the graph. Okay, and so your best bet, if we have a look here, I'm just going to zoom up quickly. Your best bet, bit blurry, is that point right there. Right there, that point right there is when x is equal to 5, a corresponding y value is going to be 15,000. So that's the point that I'm going to use into that section. There we go. So our second point in this case, we're going to use 5 and 15,000, and this is going to be our x2 and our y2. Now again, it doesn't matter if you label this one x2 y2 and this one x1 y1 because you will get the same slope. It's just the negatives will appear on a different part of the fraction. But you don't, again, you don't want to label x1, x2, and y1, y2. That is incorrect. Okay. So our y2 is 15000, and we're going to subtract our y1, which is 35000. Now, I've noticed that a few people, when we're talking to people in the chat, they said they get into the habit of getting the biggest number and subtracting the smallest number, regardless of the positions. We expect this to be a negative. By definition, it has to be a negative because the graph is going from left to right. This answer will yield a negative, and if it does, the bottom answer can't. Okay, it has to be a positive. So x2 is 5, and x1 is 0. 5 minus 0 is 5. More importantly, it's positive 5. So we know that we've done this correctly, and this one has to be correct because we're giving you a negative. So 15000, take away 35000. When you work that out, that should give you understand why that took me longer than it needed to. Negative 4,000. So so I've just worked this out straight away. The top number divided by the bottom number, 5 minus 0 divided by 5, is negative 4,000. Or in other words, every step this is going across by, it is going down by negative 4,000. Every step we go across, down by negative 4,000. So our final solution, we're going to write it in the format of y is equal to, we know our a, our intercept, it's 35000, and this is going to be minus 4000x, and that is our final equation. If you got a positive for some reason with your value in front of the x for the intercept, you know somewhere along the lines you have done the incorrect working out. You can put this straight into your calculator as a fraction. It will work it out. You can work it out manually if you wish to. So 15,000 minus 35,000 is negative 20,000. And negative 20,000 divided by 5 is equal to negative 4,000. That's how I got that negative 4,000. And just did a straight substitution from there and from here into there. Okay. And that concludes this lesson for exercise 6D, lesson 4. I hope you guys are doing really well. I'll catch you in the next video. Tell you all.